Well,
Yes.
yeah, I see it. I see it now.
Okay, now see, the question was, can you tell me what was the question? Y equal to x cube, na?
Yep. Yeah, x cubed. Yeah.
And the point was what?
-2, -8.
-2, -8. So see how I did. I calculated first the derivative f
Squared.
dash of x is
3x
3x
squared. Yeah.
squared. 3x squared. So 3x
Mm.
squared and x is -2. So can you see this?
Oh, yeah, I messed up. I put -8 instead of -2.
Yeah,
I messed up.
that's why I always say do one question with me, so that you will get the practice
Yeah.
before one day of exam.
Yeah.
So
True.
yeah, so now do it correctly. Now do it
Yep.
correctly and find out the equation.
Okay. Y is equal to 12x plus 16.
Yeah, so this is correct, right?
Yeah.
Okay, we now just go on to the next one. Mm, now, okay, try this one now.
All right.
First, read the question and tell me what they are asking.
So we're asking to find the equation of the normal.
Yes, because they say they're perpendicular to the tangent.
Perpendicular.
Hmm.
Yeah.
Now be careful and do it.
Sir.
Yes, you done?
I found the equation of the tangent.
Mm-hmm.
Um,
No need to find
now,
the equation of tangent.
yeah. So all I have to do is find the derivative and then substitute x and then do -1 over x and then
Mhm.
solve that way, right?
Yeah, directly find the normal
Okay.
equation. No need of
All right,
tangent.
then.
Yeah.
All right, I'll do right now.
Mhm.
Okay, I found the equation.
Okay, what is the
It's
equation?
-1 over 9x plus 29 over 9.
This?
Yeah.
Okay, let me check now. Tell me equation. Tell me curve.
X cubed
Mm-hmm.
minus 3x plus 1. And the
Point.
and the points are 2 and 3.
Okay. So derivative will be
3x squared minus 3.
x square minus 3. So the perpendicular derivative will be 1 over minus 1 over 3 2 square minus 3. So will be minus 1 over
Minus 1 over 9.
4 3 is 12. 12 minus, yeah, minus 1 over. This time you are careful. Minus 3 equal to minus 1 over 9 and x minus 2. So 9y minus 27 equal to minus x plus 2. So 9y equal to minus x plus 25. What you told me, you tell me this one. Why your answer is 29 in the end? Okay, suppose if you move this 9 over here, right? But why?
So I didn't move the 9. I just did y minus 3 is equal to negative 1 over 9x plus 2 over 9. And then y is equal to negative 1 over 9x plus 2 over 9 plus 3. And
No.
2 over 9 plus 3 is 29 over 9.
Now see this one. Is there any fault in my calculation? Tell me. Over here.
Sir, could you just like not like don't move negative 1 over 9 to the other side? Could you calculate it that way?
Okay, like that. I'm not moving. As you did, I will do the same. So basically what you do, y minus 3 equal to the gradient is this,
Negative
and
1 over 9
minus
minus
2.
2.
Now correct?
Yep.
Okay. So can we shift this 9 over here on the left side or not?
I mean, yeah, but can we just
Okay.
like try it?
Okay. I just multiply this minus x over 9, right? And then minus minus plus 2
Plus
over
2
9.
over 9. Yeah.
What you did? This like you did like this?
Yeah, same thing.
Okay. So then y equal to minus x over 9 plus
Plus 2
2
over 9
over
plus 3.
9 plus 3. You did like this?
Yeah, and 2 over 9 plus 3 is 29 over 9.
Yeah, you are right. You are right. I did some mistake before. Yeah, correct. This is the correct answer. So this is also 9. Okay. So finally, if you multiply whole equation by 9, you will get 9y equal to minus x plus
Negative
20.
x. Yeah.
This, in this form, you will show in exam. Okay.
Mm-hmm. All right.
Well done. Now we go on to the next one. I will share the screen again. Okay. The next one is okay. Now we come to the higher order derivative, right? Higher order derivative means the same thing you will differentiate again, nothing else.
Okay.
And
So
similarly,
the first one is you
yeah,
differentiate 2 times,
2
right?
times. Yes, this is higher order derivative. Nothing else. Not a
Mm-hmm.
big deal. But
That's
here
very
just one
simple, yeah.
more time do you differentiate. Even next time differentiation is more easy because your question will
Yeah.
become lighter one. So the third time, now next thing is after the higher order derivative, the derivative come of trigonometric function. Now we
Mm-hmm.
start the derivative of trigonometric function.
Yep.
Few formulas you have to remember. Maybe your university will not give, or if you do the online, you must have the formula, right?
Yep.
So we are teaching, so we remember always. So if the sine, cos, there are 6 trigonometric functions: sine, cos, tan, sec, cosec,
Yeah.
and cot. Right.
Cosine,
So
yeah.
we have to cotangent. We have to remember the derivative of these. So derivative of sine is what?
Cosine.
The cosine, cos, and the derivative of cosine is
Negative sine.
minus sine. Don't see screen. And then tan,
Secant squared.
secant square, and sec,
Secant x tan x.
sec x tan x. Okay. And the cosec,
Uh, let me just check the screen. Negative cosecant x, cotan x.
Yeah, only negative will come. It's like the previous one. No, cosec x, cot x, right? And the cotangent x is
Negative cosecant squared x.
mashallah, mashallah. So more than 50% you remember it. Now the things will be rule will be same if we will apply these derivative, but right time the derivative must be in your mind, right? For example, the first question. Can you tell me orally the answer of the first question?
Secant x tan x plus.
Hmm.
Let me just calculate that. Hold up.
Yeah,
5.
you can see the formula and apply over here. And 5 times cosec x, the derivative of cosec x minus
Negative
cosec x cot
cosecant
x.
x plus cotan x. Yeah.
Okay. Okay, I write here. First, I write here. I want to tell you how to finally show the answer. So the question is sec x and 5 cosec x. Yeah, this is the question. So now see. If you see this, how I will solve, I will write that y dash equal to the derivative of sec is sec x tan x.
Yeah.
And then minus cosec square cosec x cot x. Got it?
Yep. Yeah.
Either you write in this form or sometime they will say prove that something in sine and cosine form, right? Then what 1 upon cos. This is 1 upon cos. The reciprocal of cos is sec. And this is sine
Yeah.
x over cos x. You will write like this. If they say they prove that this thing, then you will apply these trigonometry. 1 over, this is 5 over sine x and cos x over sine x. The next step will be cos square sine square, cos square x sine square x, because this is sine square x and this is cos square x.
Yeah.
And then you will get here sine x cube. Got it?
Yeah.
Minus 5 cos x cube. This is answer.
Yep.
Yeah, some if they say, well, otherwise if you leave this first step is it was also answer. But if they say they prove that this one, then you will do this.
Yep.
Okay, next thing is okay, can you do this second one?
Yep. Let me do it
Try
right
this.
now.
Yeah, try this now. You will apply first you product law.
Yep. Yeah. So
For the
for x squared cosine x, I'm gonna use the product law,
product
right?
law, and the other one is easy.
Yeah. Yeah. So I'm done. Hello?
Yeah, what's the answer?
2x cosine x minus x squared sine x minus 2.
Wait, slowly. 2x cosine x,
Minus x squared
x
sine
square
x
sine x
minus 2.
minus 2. This, right?
Yeah. I mean, I can't see the board, but I think that's right.
Wait, I will share. First I write the question, then I will share. X square cos x minus 2x. Okay. If I solve,
cosine them, yeah.
if I solve this one, if I apply product law over here, so
Mm-hmm.
2x cos x plus x square minus sin x, and then minus 2. Mashallah, mashallah. You have done 100% correct. Wallah. So from first step, I got it. Okay. Now, next thing is, okay, try this one now.
The third one.
Oh, yeah, third one. What you will do in this?
Quotient rule.
Yeah, apply.
All right. Sir.
You have done? Tell me
I
answer.
mean, yeah. I mean, I think it's. I think I might have done something wrong, but it's cosine t minus cosine squared t squared.
Cosine square t.
No, cosine t
Uh,
minus cosine squared t squared
t square will also come. And then
minus sine squared t squared
sine square t square. And then
over 1 minus cosine t squared. Like brackets 1 minus cosine t squared.
it's a very big thing you bring. Okay, let's see. This is new thing I'm learning, wallah. Okay.
I think it's
Uh,
wrong.
no, then let's see. Maybe it's some mistake. You cannot change angle. Whatever
Mm,
the things comes, you cannot change angle. Okay. So first of all,
yeah,
I will write over here minus 1 minus cos t whole square. The v square. Okay.
yeah.
Now I will write v over here. 1 minus cos t. This is v. V u dash. What is u dash? Simple cos t. You agree with me?
Sir, can you enlarge the board?
Yes. So see, v square. This is v
Yeah,
square.
yeah.
V u dash
Mm-hmm.
minus, now u is sin t,
Sine t,
and v dash. V dash means the derivative of
sine t.
is sin t, right? Now whenever
Yep.
you multiply, the only mistake you are doing, when you multiply the t square also. You don't have authority to multiply an angle. Angle remains same.
Oh, yeah, yeah, yeah.
You remember now? Your teacher
Yeah,
told you. Yeah. So now multiply this, you get the rest of the thing. I believe that you have done correctly. Cos t minus cos t square. Cos square t. You will read it like this. Cos
yeah.
square t.
Cos squared t. Yep.
Yeah. Minus sin square t. Right.
Yeah.
Divided by 1 minus cos t whole square. But still question is not finished. There is one step in I need to tell you. See, What's that step? I will take
1
some.
minus cos t is equal to, I don't know.
No, that is 1 minus cos square t, right? Here
Oh,
is
factor out the cosine.
yeah,
Cos t
numerator.
from the
If I
numerator.
take minus common from numerator, can I write like this? Cos square t plus sin square t.
Wait, wow. What happened?
I take just minus sign is common from numerator in this
Oh,
step.
yeah, yeah. Yep, yep,
So the bracket will come like this, and this
yeah,
whole bracket is equal to 1. This is 1. This is 1.
mhm,
Because
yep,
there is a formula. Sin square t plus cos square t equal to 1. You must remember it, right?
Wait, sir, in the numerator, it's 2 cosine and 1 sine, like
Yeah,
in the numerator.
yeah. So basically, I took minus sign is a common from second and third term. Minus, because
Oh,
these are the,
isn't that minus cosine? Like cosine t minus cosine squared t?
no, this is C. See, this is cosine into 1 is cosine, right?
Yeah,
Then plus minus minus cosine square t. You got
yeah,
it?
yeah,
Then next is minus sine square t.
yeah,
So minus sine. So the answer is cos t minus cos square t minus sine square t. You understand this step?
yeah,
So
yeah.
in this step, only from these two term, I took minus sign is common.
But how is minus sign common when there's only one sign?
There is both are negative. If I take negative outside, both will become positive. See, this is
Oh,
negative, this is negative.
okay,
I took it
okay,
outside because I
okay,
have
yeah.
a sense that sin square t plus cos square t is equal to 1. You know this formula?
Mm. Yeah, yeah, I know. Yeah,
Yeah. So that's why I wanted to convert this whole thing into this formula. So my question will be precise.
okay,
Then the denominator will be 1 minus cos t whole square, right?
yeah.
Still some work is remaining. Can I take negative is common from numerator?
Negative is common from numerator?
Can I take negative
Uh,
common from numerator? What will be inside the bracket? 1 minus cos t. Can I
yeah,
write like this? And
yeah,
1 minus cos t whole square. So 1 square cancel with this one.
yeah.
So my final
Negative
answer,
1 over
yeah, negative 1 over 1 minus cos t.
cosine t.
Yeah, this will be. This is final answer in the red. I write on the left side. This
Alright.
is the final answer. Got it?
Yep.
Yeah, this kind of things you will control now. Now see another thing. If we see the trigonometric, so this was only thing in your. Okay, I will give you from my own
Okay.
because here is nothing more given. So question is sin t minus cos t upon 1 minus cos square t. This is your question, okay? F of t
Okay.
equal to this. You need to find f dash of t. Do it.
All right. Sir.
Yes, I am.
Okay, I got a really big fraction.
Very big fraction.
Yeah.
Okay. Okay. Send me picture. Better.
Alright. Alright, it's sent.
So I'm trying to see it. Okay. So cos t. So first of all, you did what? Cos t sin t. Cos t plus sin t. This is v,
Yep.
right? You
Mm-hmm.
write
Yeah.
v, and then derivative of u. Derivative of u is 1 minus. Why you write derivative of u is 1 minus cos square t?
Wait, what?
No, so first of, you use that formula which I told you. V u dash.
I'm sorry, sir. It's just a habit, because we've been using like u prime v minus v prime u for years, so it's like stuck in me.
Yeah, that's why
My bad.
I in starting I change it because
Yeah.
because of only this people do the mistake, right? So I
Yeah.
started
True.
in the beginning I started with v. Even you
Mm,
product law also I started with v, and
mm,
quotient law also I started with v. So
yep.
I think this is correct. V u dash. So v you write 1 minus cos square x t, and u dash. U dash you write sin t, cos t, cos. Yeah, correct. Only you write derivative in the beginning. It's no problem. So, but you
All right.
write the derivative of u. It's perfect.
Yeah.
And then v,
All right.
right? Then minus
Yep. V
derivative.
prime then u.
Yeah. Then the derivative of denominator. The derivative of denominator you write wrong. How you write
No,
the
but it's supposed to be v squared, no? Like 1 minus cosine squared t squared.
this step you write in the quotient law is correct, but the derivative you took wrong. Now see, I will solve for you. You will see. First, I write this question. F of x equal to sine t minus cos t divided by 1 minus cos square t. Now you will see my board and I will solve for you. So first of all, I will write u dash. U dash will be cos t plus sin t. You agree?
Yep.
Now v dash. What is the derivative of this one? This derivative of this one will be minus 2 cos t into cos the minus sin t. This is the derivative of denominator. Derivative of v. This is v dash. This is v dash. This one.
Or
How,
how?
how to take the derivative? You see, v is 1 minus cos square.
Oh, it's cosine squared t.
Yeah,
Okay.
cosine square t. So 1 is 0, right? First
Yeah.
we bring power down. 2
Mm-hmm.
cos t. Then inner
Yep.
function, derivative of inner function. What is the
Sine,
derivative of inner function is minus sin t.
negative sine. Yeah.
So finally the answer will be what?
Negative
Minus
2
minus plus
cosine t
2
minus.
cos
Yeah.
square. So 2 cos t, 2
Yeah.
cos t and sin t. This, right?
Yeah. Yeah.
So this I will use now. So now the next thing is you will see what we will do. V square means 1 minus cos square t whole square. And here we will write V 1 minus cos square t. And U dash. U dash mean cos t plus sin t. And then minus. Now what we will do?
Negative minus 2 cos t sine t.
Yeah, minus 2 cos t, no, plus 2 cos t sine
Yeah.
t, and the
Times
numerator, huh?
sine t minus
Sine
cosine t.
t minus cosine t. This, the next is very easy. You will just expand and get the answer, right?
Yep. Yep.
Yeah, that's the thing. Oh, now I will give you one more thing. Is suppose a question is in this 10 is given, 10x over sine square x. Try this.
Mhm. All right, sir. I got the
So,
fraction.
yeah, you got it?
Yeah, I got the fraction.
Yeah, of course. So what's the answer?
It's secant squared x
Okay. Secant square x
times sine squared x
times sine square x
minus 2
minus 2
sine x cosine x
sine x cos x divided by
times
sine
tan
4x.
x.
Divided by
No, minus 2 sine x cosine x times tan x.
10x. Divided by
Sine squared x squared.
sine 4x. Okay. So let me check. Sec square x sine x. Sine x v and this 10 ka derivative sec square x minus 2 sine x cos x and 10 is remains same. Mashallah, mashallah. Perfect. Correct, you have done. That's I wanted that. This time round you have done correctly. Now the next thing we will see.
Sir, can we start with the continuity, like the
Yeah, now we
worksheet that I sent you, the
yeah,
2.2?
yeah, now I will see. Now in the continuity, first of all, few rules I will tell you. This 0 upon 0, if this comes, if comes 0 upon 0, this is undefined.
Yep.
And if 1 upon 0, it's called infinite, and 0 upon anything is 0, and infinite upon infinite is been, it's in infinite, right?
Mm-hmm.
And one is negative infinite and one is positive infinite also. These all things comes. So whenever we apply the limit and check the continuity, the main thing is we have to check the negative. Suppose if I say a function is f of x equal to piecewise function, my piecewise function is x square plus 2 and one is 2x plus 1, and one function is my here is 3x, like this. So this this function is here is x is greater than minus 1 and greater than minus 1 and less than equal to 1. and this one is x is greater than 2, and this one is x is greater than equal to 2, and less than 3, right? This is my
Yeah.
piecewise function. I want to check that this is differentiable or continuous. Either this function is differentiable and continuous. If function is not continuous, it will be not be differentiable. Okay.
Yeah.
One thing you must remember: if not continuous, it will be not differentiable. This is first thing. Another thing is, one is the jumped continuity. One is the whole and this one, right? One is whole.
Okay.
In the whole is, one is continuous, one is differentiable, and the third one is discontinuous. Then this is called whole. Now, first of all, what are the rules to check the continuity? First of all, we will see that if we want to check on one means if it is less than 1. So if it is less than 1, for 1, if I want to check less than 1 means this function I will check, right?
Okay.
So
Yeah.
suppose it is less than 1, not like less than equal to 1, only less than 1. And then this one is greater than equal to 1 as well. So less than 1 means this lies on this function. So in this function, if I check it, so if I check it in this function, if I put 1 in this, answer is 1 is square plus 2 is
3.
3. Okay. Now next thing, if I check on this function, means if I want to check 1 plus, if I want to check 1 plus, where I will go? 1 plus will go in this, right?
Yeah. Yeah.
So 1 plus will go in this. So 1 plus will go 2 into 1 plus 1.
3.
Answer is 3. So this and this is continuous. If left side of limit f of x, right, equal to right side,
Right side of limit.
yeah, of the limits are equal, this is called continuous, right?
Yeah. Yep.
And now I will check this one. Now for 3 I will check 3 minus and 3 plus. For the point of 3, for the limit of 3, it, for the domain of 3, it will give you the answer. Now we will check on this also. Now if I check on 3 minus first, 3 minus. So 3 minus means which function I will check? This one.
Last one.
Okay. So 3 into 3 is 9, right?
9.
So this
Yep.
is not continuous with this one, these two. So these two are continuous, but this is not continuous, right? So this kind of function is called whole.
Okay. Whole. So whole is like two continuous functions, but one is not.
One is not continuous function. This is called whole, right?
Yep.
Okay. Now, how to check the differentiability? So the check.
Find derivative.
Yeah, find the derivative. If I differentiability, I think it's very easy. Huh? You will apply the derivative f dash of x, and
Okay.
in this derivative you will put 1. So answer is 2. Finite answer. Right? If the finite answer is come, means this is differentiable.
Yeah.
So derivative you can check easily. All are differentiable, right?
Yeah.
So if the function is continuous, of course it will be differentiable also. If
Wait, sir, all of them are differentiable or just the first two?
the differentiable function, you will check one by one, this one and this one also, right?
Okay.
Yeah, because in this, if you will check, it will be 2, and this, if you will check, it will be 3, right?
Yeah. Yeah.
Like that. Now we will see this. I just give you my own example. Now we will see from your sheet, and we will see how the kind of questions are given. But first, I wanted to tell you the general idea of this one. Now, where is that? Okay. Let's acrobat with acrobat. Yeah, this was the sheet. So this was one of the thing. This is not D-L'Hopital rule you use in this. That was in that rule. What you do, you check that how it is 0, right? If we apply this limit on this, what is the limit? Can you see? Limit is, I think I can see the limit is x tends to infinite, right? Am I right?
Yeah, I think so.
X tends to infinite, because I can see x
Yeah.
tends to infinite. So
Mm.
x square plus x minus plus 1. So before applying limit, would you know what we our responsibility to cancel x? So if I
Okay.
take x is a common from numerator and x is common from denominator before applying the limit. So if I take x is common from numerator, it will be 1 over 2 over x, 1 plus 2 over x. Okay.
Mm. Okay.
And here also, if I take out x common, so x plus 1 plus 1 over x. Are you getting?
Yeah, sir. Just 1 second. I want to find the. Just let me find something real quick. 1 second.
Mm.
Never mind. Okay, sir. I'm ready.
Okay. So you see that what I did in this question,
Let me just
I took,
enlarge.
yeah, check it.
Okay. I can't see the board, sir.
Okay, wait. Now see, can you see the screen? I share the screen.
Uh, it's. I can see it, but it's really small right now.
Okay, now see
Oh
the
no,
board.
I can see it now. I can see it now.
See, x is common. I took x is common, right?
Hmm? Yeah.
Now I can if I take x is common, numerator will be 1 plus 2 over x. You agreed?
Yeah.
Okay. So if I take x is common denominator, you agreed? This one?
Uh-huh. Yep.
Because x will remains over here, here 1, here
Mm-hmm.
1 upon x. Now this is
One
cancelled.
over X. Yeah.
So now always adopt this method. This is called L'Hopital rule. This is divided by x plus 1 plus this. Now apply
Mm-hmm.
limit. Now apply. If you apply limit, I told you that 1 upon infinity is what? 1 upon infinity is 0.
1 upon infinite is 0.
Yeah. Remember.
Okay. Let me write that down.
Yeah. This will 1 upon
Okay.
infinity is 0 means 1 plus 0. And
Mm-hmm.
here infinite will come. Here 1 and here 0. So finally you will get 1 upon infinite, that is 0.
Infinite plus 1 plus 1 over infinite, which is 0, which is 1 over infinite.
Yeah.
Wait, isn't it 1 over infinite plus 1?
Yeah, infinite plus 1 plus 0. Because the 1 upon infinite again 0.
Yeah.
So finally the answer will be 1 upon infinite. And 1 upon infinite
Wait,
is 0. Right?
wait, so sir, where'd the 1 go? Like, isn't it 1 over infinite plus 1? Like,
You
the
know,
final answer?
if you add in very big number, if you add in
Ah, true.
1, it will be infinite.
Yeah.
Got it? That
Yeah.
makes sense?
Yeah.
Okay. Now you see your sheet. So the first answer is 0, right?
Yeah. Yeah.
So like that you will apply. The main thing is how you will apply to get the finite answer. If you will
Mm.
apply, if you will apply directly limit, it will give you infinite result, right?
Yeah.
That's why you have to apply in after taking something common. Sometime
Mm.
they provide you the factorization also in that. So you have to factorize. For example, if I say this one, can you tell me what is the limit over here? This is also extends to infinite. Question number 5.
Honestly, sir, because like I don't have the question sheet with me. It's this teacher sent it to me like this, so I have
Okay.
no idea what the limits are.
So suppose this is infinite, right?
Mm.
The main
Yeah.
thing is we have to learn in this question how we will tackle this situation. 3. So this is a
Mm.
question. Now see my screen. Now you will see the board. On board I write the question. Now do you have any idea
Sir,
what I should
which
do?
question are we using? Which
Question
question are
number
we
5.
doing?
Question number 5.
Okay.
So now you tell me what to do. You try this.
Okay. 1 second. Um, what was it?
The same method. Whenever infinite come, numerator should be free from x. Got it?
Mm.
Because
What?
if you put infinite over here, it will be infinite over infinite square plus 3. It will be infinite. No. So
Mm.
you will take this is x cube. Try to take x square is common, right?
Okay.
So it will cancel with this one.
So so
Or x cube,
4 plus
x cube
3
is common.
over.
So 4 over x, right? Plus
Okay.
3 over x cube. You got
Yeah.
my idea?
Yeah, I get it now.
Yeah, like always, whenever infinite is there, just remove this one.
Mm. Oh,
Just
okay.
remove this one, right? Completely.
Okay.
I did not take x
All right.
square common. I take x cube common. I want to cancel this completely.
Mm.
4 over x plus 3 over x cube. Now apply limit. X tends to infinite. If I apply limit now, 1 over this 4 over infinite, 0,
Infinity. Yeah, 0.
0. And
Plus
this
3
one,
over infinity is 0.
0. So 1 over 0,
So it becomes infinity.
yeah, this is answer.
Okay.
But you have to show this one,
Mm.
not directly. If you will show
Yeah.
this is the rule of
Okay.
limit. This is basic main thing is this one. If you control it, you will get one question in exam. 1 or 2 question they will give you like this. Then
Mm.
you have to take common. Now see, question number 6 we see. This looks very interesting, in which you will use some factorization and some technique to make it finite. It look infinite, but you will make it finite. Again, the limit is given, x tends to infinite. First I write the question and then I will share the screen. X plus 1 divided by 2x square plus 2x plus 1. Yeah, now I will share. Now can you tell me any idea what you are going to apply in this to cancel x and
Mm.
something like that?
Take 2 outside in the denominator,
Mm-hmm.
and then it's gonna be 2
Mm.
x squared plus x plus
X square plus X plus 1.
1 over 2.
What's the use of that? There is no
That's
factor.
1 over 2, right?
Yeah, 1 over 2. But nothing will happen with 1 over 2.
Mm.
So what I'm going to do, what is it? Can you take X common in the numerator?
X common in the numerator? Yeah, you can.
Okay, X common in the numerator. Take this one. What I should write here? Tell me.
1 plus 1 over X.
Good. And denominator? What I should write here?
Take X out.
Then?
It will be 2X plus 2 plus 1 over X.
Good. So X cancel with X?
Yeah.
Now, if apply limit, what will come? Tell me.
So limit is 0 or is it infinity?
Numerator, yeah, it's infinity, sorry. Yeah.
Okay. So 1 plus 1 over 0 over 2, 0 plus 2 plus 1.
In numerator, what will come?
Wait, 1 second, sir, 1 second. Numerator, wait, 1 over infinity is 0. So 1, it becomes 1 in the numerator.
Okay, very nice.
1 over infinity plus 2 plus 0.
Yeah.
So 1 over infinity, which is 0.
Infinity plus 1 plus 0. Yeah,
2 plus 0.
Excellent, boy. You reach on the correct concept. Like this, you can handle. Now, perfect?
Yep.
Very good. So now see,
Sir, can we do 7 and 8? I mean,
yeah, sure.
They look.
Yeah, I write here 7 and 8. So question number 7. If I see square root of 2x square, whatever I can see with my less eyesight, divided by 2x minus 1.5 only, limit, and x tends to infinite. Okay, you try this question. I show your board. Yes, you try this question. Let's see how you will do.
So the first thing we want to do is factor out the numerator, right? Like make the numerator 1. Is that what we're supposed to do? I really don't know. Wait, so instead of making a square root, make it to the power of 1 over 2? I don't know.
They give very different question.
How do I approach this? Radical 2x squared plus 3. 2
2x plus 3 in the denominator, they give 2x plus 3.
Factor x out in the numerator?
We cannot make factors. Let me check the question again. It's a little bit different thing. 2x square plus 3 and 2x plus 3. The question is this, huh? And answer also they write. And they write the answer minus square root 2 of 2 over 2. Okay, let's we try. This look interesting. Okay. Okay, what I do, do you know if I say 2 equal to square root of 2 square root of 2. Can I write like this?
Yep.
Because 2 equal to square root of 2 is
radical 2 squared. Yeah.
So this type of concept I want to do it over here. So this will remain same, and this if I write 2x plus 3, 2x plus 3, this one. Okay. Did you ever listen about the word conjugate?
Yeah, yeah. You multiply.
Is
Forgot
surds,
what it
in the
was.
surds you have learned conjugate 2x minus 3 over 2x minus 3,
Yeah,
right?
yeah, yeah,
So
yeah.
this will become 2x square minus 3 square,
Mm,
and here 2x minus 3 and 2x square plus 3. So due to this, the denominator will become 4x square minus 9, and here is 2x minus 3 and 2x square plus 3, like this.
mm.
Now if I negative 2, 2, 2 over 2. Okay, if I apply over here now the limits, I cannot apply the limits until I take something common. So if I take x square is common, so there will be 2 over x minus 3x square, and this will be 2x square plus 3 divided by this will be x square, and this will be 4 minus 9 over x square. Now this will cancel with this. If I applied the limit now, infinite, limit x tends to infinite. So 2 over infinite, this will be 0. But this will be minus infinite. No, there is something in this. What I'm feeling, limit is change.
Yeah, I feel like the limit is
Maybe
different or
limit is
something.
change. Otherwise, our answer must come. Maybe limit is something over here, minus infinite or something like that. Here,
Mm.
can you see the question number 8? The limit, can you?
Honestly, it just looks like a line. It looks like it's definitely not a number though. It's either infinite or negative infinite.
Okay, this, I think this is clear.
Yeah, this is a clear question. Let's just do this.
Yeah, this is very nice. If you see this mm, in this question, 1 over x plus 2 whole square, x is equal to
Yeah.
minus 2. Here we will see the continuity, right? So they
Yeah.
said to check the function continuous and differentiable and
Mm.
discontinuous. So discontinuous or continuous and differentiable, what I told you, we check the plus and minus, right?
Yeah.
So first thing what we do, we check at x is equal to minus 2. So left of minus 2 and right of minus 2. So if you apply minus 2 over here to before if you apply minus 2, the denominator will become what?
0.
0. So 1
So
upon
you
0,
can't. It's
yeah.
undefined. Yeah.
So 1 upon 0 is become infinite.
Undefined. Yeah.
So undefined, yeah, infinite. Undefined is different. Undefined is different thing. Infinite is different thing. So
Mm.
undefined is 0 over 0, right?
Mm.
And this is infinite, right?
Okay. Yeah.
So
Yeah.
if this is infinite, so infinite is as discontinuous. This is discontinuous. The continuity is break when it become
Okay.
infinity. You know, when your graph is become parallel to y axis, some reciprocal graph goes parallel to y axis and they continuously accelerating over the y axis. That is discontinuous.
Mm.
Next is if you see the function is 1 over x square plus 1, this one.
Okay.
So in this x is equal to minus 1, we will check. So minus 1 square is what? Yeah, this time around the things will be changed. Minus 1 square will become positive
Yeah. 1 plus 1, so it's 1/2.
1 over 2. So 1 over 2 is finite number. So the
Mm. Yeah.
function, your function become continuous at x is equal to minus 1. Got it?
Wait, sir. So how do you determine whether it's continuous or not? So I mean, if
Basically,
it's
see the if the function gives infinite, result is like this, infinite, that is discontinuous. If the function is given the proper result, 0 or 1 by 2 or something like that, right?
mm,
Its mean
yeah.
is continuous. Its mean is continuous. This is a major difference. Got it?
All right.
You will directly apply the value of this. This is not piecewise function. If the function is not piecewise, you will direct apply and check. Later on,
What
after
do you mean? What do you mean by piece size? What is
piecewise
that?
function, when I start discontinuity, I write the piecewise function in the bracket and like that, right? In the piecewise
Uh,
function, yeah, the piecewise function is like that. I just show you again on the board. See, the piecewise function is like that. F of x is under root x plus 1 and x plus 2, like that. X is greater than 2, x is greater than, x is less than 2, x is greater than 2 and less than 3, x equal to 3, like this. This is piecewise,
mm,
right? There are 3 pieces.
okay.
We have to check
Oh,
where we can apply. This is piecewise
okay,
function.
okay, okay.
So
Okay.
now we come on to again few more example I will give you. I have some examples also for you. I will give you right now. So
Mm,
after this sheet, I will give you. So first we
fair enough.
complete this one. Okay. So your question is 1 over x square plus 1. So at -1, you have to check your answer came. Because of this -1, the square of -1 become plus, right?
Mm,
So with this become a continuous function. And next is, when the function gives in the modulus form. I revised you the modulus first. Modulus is basically if somebody say the function is f of x equal to mod of x, mod of x,
mm,
right? Mod of x means this is V graph, like this.
yeah, yeah.
Y is equal to x is this one, but due to this,
Mm,
it's go like this, and this is finish, right? So
yep.
V graph is modulus function.
Mm-hmm.
Modulus mean all positive.
Yep.
So if one more thing I want to tell you, that if you have value is x square plus 1, solve this one. So what you will do, you will write two things, minus of x square plus 1, and one thing is plus of x square plus 1. When you
Mm-hmm.
will open this one, the answer come plus minus. Got it?
Yeah.
Yeah, whenever modulus come, when you remove the modulus, there will be two values will come, y is equal to plus and y is equal to minus. So for
Yep.
example, if you have one more function is x plus 2, x minus 2, like this, x minus 2, this is modulus. So this will be have two solutions. One is minus x plus 2, means this will become minus, sorry,
Mm-hmm.
this will become minus x plus 2, and the other one will be x minus 2, right?
Yep.
This is because of modulus. Whenever you
Modules.
remove the
Yeah.
modulus, well, you take plus minus, plus of function and minus of function. So because the function is
Yep.
goes negative side and positive side, but it will not go
Yeah.
down. It will be upper
Mm,
than x-axis. It will be upper than x-axis.
yeah.
Modulus mean. So one more very simple example is this: if it is minus 5, answer of minus 5 is 5, and answer
5.
of
Yeah.
plus 5 is also 5. This is called absolute function. Another
Mm-hmm.
terminology is absolute function. Absolute mean positive. Got it?
Yep. Yep.
Now see. Now here you see. So modulus function is given. So this number 3, if you see the function is given mod of x divided by x. Now this in this function, they divide into two pieces. One piece is x is at x is equal to 0. So they
Mm-hmm.
will check this function before 0 and after 0.
Mm-hmm.
What will be the
Yeah.
behavior of the function after 0 and before 0? What I told you in the beginning, if before 0 and after 0, if the function is change, if the function is change, it's discontinuous, right?
Yep.
So that's called sometimes jump discontinuity. So let's see how it will happen. So minus x over x and the other one is plus x over x. These two things. So minus x
Yeah.
over x will appear when x value is less than 0. Of course,
Yeah.
if x value less than 0, then this function will appear.
And
In
if
x
it's greater
value
than 0,
is
then it's
greater
x
than
over
0,
x.
this function will appear. First of all, you have to
Mm.
write like this, right? The next
Okay.
thing is, first you will check on 0. 0 is basically at 0 it will be undefined, right?
Yeah. Yeah.
So before 0 and after 0 it will be continuous or discontinuous, but at 0 it is not defined.
Yeah.
When it is I just get from the first step, this is discontinuous, because on the 0 it's, you know, it's check.
On the it's
It's
yeah.
check on the 0. It's on the 0 it is undefined, means minus and plus is no matter, no use, right? Now
Yeah.
minus, on the minus it is minus one answer, on the plus it is plus one answer. Both answer are different, so
Yeah.
it is,
Not continuous.
it's not continuous, right?
So, sir, what does jump discontinuity
Yeah,
means?
this is
Or
jump
what does that mean?
discontinuity because of 0. At x is equal to 0, this is called jump discontinuity, that before is different, after is also different, and on x is discontinuous. This is called jump discontinuity.
Okay, let me write that down, sir. 1 second.
Yeah, sure.
So, can you repeat it real quick so I can write it down?
Yeah, this is, if the continuous before and after, in positive and negative, it is discontinuous, and in the middle, it is undefined.
If before and after is discontinuous,
Yeah,
and in the
before and
middle it's
after is,
undefined, then
yeah,
it's
before and after it is different, limit is different, and in between it is undefined. This is called jump continuous, jump discontinuity.
okay.
Yeah, now next one. Now next one in this, so if you say this is defined in 3, at 3 we
Mm-hmm.
will check. At 3 we will check f of minus 3. First of all, check at f of minus 3. F of minus 3, it's and f of plus 3 we will check. So first of all, if we check f of minus 3, if it is come, then the problem will be solved. So f of minus 3, they are saying that check on f of minus 3. F of minus 3, what it will be?
Undefined.
Undefined. Now f of 3 minus, before 3 we will check. F of 3
Mm-hmm.
minus, for f of 3 minus, if we want to check it, first of all we will make it factorized. So factorized,
Okay.
so this will be factorized, this will be cancelled, right?
Mm-hmm.
And
Wait, sir, we're doing f of minus 3 before f of minus 3 or after?
before 3 minus means before 3, right?
Okay, okay.
So before 3, if means if you will take whatever you will take, the answer will come negative, right?
Mm-hmm.
And if after 3 you will take this one, the answer will be positive.
Okay.
So this is not discontinuous. This is not continuous.
Wait, so what does it mean by removable discontinuity?
Yeah, this is called removable discontinuity because at minus 3 it was undefined. But when we make it the factorize, so then we get the conclusion that the before 3 it is applicable and after 3 is applicable, right? This is a kind of jump discontinuity also, but jump discontinuities occur mostly on 0, right? This is also a kind of jump discontinuity because before and after it is different, and in between it is undefined, right?
Yep.
Okay, next one is, I think your school is
This is a
already
definition of derivative.
yeah, this definition you already done, right, with me.
Yeah, yes, easy.
So
It's
in
easy.
this definition you can check also this like that. So this
Oh, sir,
one,
can we do question 2? Yeah.
yeah, this one I'm looking, this look interesting. As I told you that whenever modulus is given, what you do, one time you take minus and one
Two
time you take
functions.
plus. Yes, two functions.
Yeah.
So if you take a minus, you see this minus of 2x minus 6 and plus of 2. Of course, this will occur when x is less than 3.
Yep.
And this will occur when the value of x will be 3 or greater.
Okay.
Why they write 3 or greater?
Because it was given x is
yeah,
equal to 3.
yeah, that was less than 3. 3 was not used. So here
Yeah.
3 or greater you will use. So if you use on 3, so
Mm-hmm.
on 3 it will be 0, right? 0 is
Mm-hmm.
the answer, right? 0 is valid. Now 3 plus 0. Now 3 plus 0, on 3 plus 0 you will put where? You will put in this.
Yep.
2x minus
Mm-hmm.
3. 3 plus 0. If you put 3
Wait,
plus
sir. 3 plus. So then it goes. It's greater than 3. No. So shouldn't it be the second one?
is greater than 3 mean, but we always put 3. We cannot change the value over here, right?
Yeah.
We
Yeah.
imagine it, but we always put
Yeah.
3. You cannot change it.
Mm-hmm.
So this will be
Yep.
0, and we only 3 plus 0, we decide which we have to use this equation or this equation, only for this.
Yeah.
So we
Yeah.
will use this equation. For this
Mm-hmm.
equation, it will be 0, and for
Yeah.
this equation, it will be what? For this equation
It
is
will
also
also be
0,
0.
right? So
Yeah.
both are same.
Yep.
If both are
Well, it's
same, continuous.
continuous.
Voila, you learn now, right?
Yep.
I have one example also. I just take out this. Wait, I just take out this and show you. Maybe it's in my WhatsApp. Well, when we load the WhatsApp on laptop, it's dead become.
Oh
And
yeah, it takes a long time. Yeah.
yesterday, one seventh grade student did what? I said just send all the pages in my email, but she take the picture and send 80 pages on my WhatsApp
Oh.
and
Oh
said,
my
teach
god.
me. When I start loading over here and sharing the screen, it's like that. We kill the
That's.
WhatsApp. Now see it's again moving and moving. That was very good example. I won't show it. Okay. So you are in American system. The next year is the last year, grade 13.
No, this year's the last year.
This
This
is
year's the
last
last
year.
year.
So you have
Yeah, my last year. Yeah.
okay.
I'm graduating.
Oh, very nice. So, but only
Yeah.
the situation is hurdles nowadays. So they promote
Yeah.
next class.
No, I'm in grade 12 right now. So
Mm,
after these exams, so because I missed the term one exams, so I have to do the term one material exams. That's why
okay.
I'm doing derivatives and all these. So
Mm,
after tomorrow, when I give these exams, I'll finally be able to graduate.
very nice. Very nice.
Yep.
So,
No
okay.
more school, man.
Yes, you are happy now from now.
Yep.
Yeah, of course. Yes. Where is that? Yeah, I think it will come now. Yeah, okay. Now I will show you my board, and you define you one more example related to the continuity. So,
Okay.
so can you see the board?
I can see it. Yeah.
You can see the board, right?
Yep.
Okay. And let me just put this smaller. So I need some part of board also. Okay, first of all, I will write the question and then explain you. Just wait for 2 minutes. F of x equal to 1 piecewise function square root of x plus 2 when x is less than 2, x square minus 2 and 2x and less than 3 and 2x plus 5 and x is greater than or equal to 3. So first thing we will check on f of 3. This will give 11. Second thing is limit x tends to 3 minus. This will give f of x equal to 3 square minus 2 7, and then limit x tends to 3 plus, and it will give you look at this, 2 of 3 plus 5. Okay, now if I say you to see this question, see this question now. So
Yep.
can you try this question? I want you should try.
What do I find? Like, what's the
Yeah,
question?
you have to check that this continuous or discontinuous.
Okay.
Differentiable is okay, it is differentiable, but check the continuous or not.
Okay.
So how to do it?
So for these type of questions, do we use the first equation always as like as a waypoint? Do we take that as a
You will
reference?
use the 3. For 3 you will check, right? Before 3 and after 3 you will check. So before 3 and after 3, what will be the function behavior? So if you will check
But
the,
sir, why do we choose the number 3 though? Like, why do we choose the number 3?
yeah, because we will compare 3 and 2, right?
Okay.
They both we will check, first 3 and 2 both. Because
Okay.
of greater than 2, we are checking the second and third discontinuity, discontinuous or not. First and 2 of course continuous, right? We will check second and third. So if you check the 3,
Okay.
if you put for x is 3 means less than 3. If you put less than 3, what it will be?
Less than 3, then it'll be less than 3.
You have to check
It'll
it
be
3 less
either
than
1 or
3.
2, no?
Yeah. One thing I missed in this question, sorry. I did not tell you where you have to check the discontinuity, right? In the question, it will be given that. It is given that at x is equal to 3, you have to check, right?
Okay.
Otherwise, we have to check the other points also. So they will say that at x is equal to 3, they find out the function is continuous or discontinuous. So at
Okay.
x equal to 3, we will apply this one. 2 3s are 6 and 6
To 6 with 11.
11. So f of 3, it is 11. Now 3
Yeah.
minus. The 3 minus means we will use this one.
Yeah. Second one.
3 square minus, it is 7, right?
Mm-hmm.
So 3 minus and now 3 plus.
The third one.
Yeah, 11, right?
Yep.
So at 3, if I put 3 in between, f of 3 equal to 11. So this one and this one is changed.
Wait, sir. For limit x is equal to 3 minus, can we not use the first equation as well since it's less than 2?
Yeah, but basically that is less than 2. Yeah, we can use that one also. If we will use that one, you will get 8 as I write over here.
Okay.
Right.
Okay.
But that is also different. So this one and this one both different, right?
Okay. Yeah.
This is discontinuous, right?
Yeah.
Yeah, like that you will check in exam. Now you are confident about it?
Yeah.
Yeah, that's very nice thing. So if you have any problem, but trigonometric differentiation is still I feel that you are weak in trigonometric differentiation. The rest
Mm,
you did well. Only trigonometric differentiation. You need to
wait, let me
you need
just
some practice,
check.
right?
I need to memorize the
Yeah.
different
Yeah, just
yeah.
because you did not memorize the formula also. Sec is
Mm,
10. What is the derivative of 10?
um cosecant squared x.
Wallah lazim.
Wait, it's secant squared x. Secant
Yeah,
squared x.
no, yeah, that's why I asked this one, right?
Yeah.
What is
I
the
need to
derivative
memorize
of,
them.
okay, what is the derivative of sec square x?
Secant squared x
Hmm?
derivative
Yeah,
negative tan x.
no, it's not a formula. You have to do it.
Wait.
This time round, I just,
Oh,
this you have to do
secant
it.
squared. Yeah, 2 secant x
Hmm.
times
Hmm.
secant x tan x. So 2 secant x times so 2 secant squared x tan x.
Yeah, deliberately I asked you very jumbled question. But now, mashallah, your voice is very nice.
Yeah. Thank you,
Okay.
sir. Thank you.
Okay, thank you very much. So have a nice
Thank you,
time with
sir.
me, right? If any
Yep.
problem comes,
Yeah,
you can
absolutely.
ask me tomorrow, right?
I will, sir. I will.
Okay, thank you. Bye
Wish
bye.
me luck, huh? Thank you,
Yeah,
sir.
inshallah, inshallah, inshallah.
Yep.